Welcome back, friends, to the channel. We have been doing the sums on integration methods of substitution. Hope you are practicing the sums thoroughly and then regularly watching the videos so that track will not be missed. We will continue in this methods of substitution a few more sums and then go to the next concept today. Let us take up this sum, go to the right screen straight away. These sums are particularly examination point of view, very important sums, what we are now trying to do. First one, integral dx by 1 plus tan x. So this sum is a very important sum in the examination. What we do in the numerator, only dx is present. That is just, you can imagine 1 by 1 plus tan x, like that. This one we will do like this. Integral dx by, first we convert tan x to sin x by cos x. We can convert tan x to sin x by cos x. Then what happens? After you find the LCM in this, cos x will go here. Later this cos x goes to the top. So cos x dx divided by cos x plus sin x. This is what you are now having. Next step, what I do, I will add and subtract to the numerator cos x plus sin x. Okay. See what I'm doing. Add and subtract. Cos x plus, add and subtract cos x plus sin x. Add and subtract cos x plus sin x to the numerator plus cos x minus sin x. This entire term I'm adding now. We don't worry this one. Yeah. Add sin x plus cos x minus sin x. That's what I wanted to do. Actually, this cos x will come later. So add sin x plus cos x. This is actually conversion. We are trying to do some steps, some technique to solve this sum. Add sin x plus cos x minus sin x to the numerator. Then actually what we are having in the numerator, cos x we are having. So by adding this term, you will be getting what? Just observe what you will get. Afterwards, I will tell you. Cos x plus all these three terms you add. Sin x plus cos x minus sin x. Whole thing divided by denominator. Now understand, sin x and sin x anyway go cancel now, even after adding. But cos x plus cos x, when you add, you will get actually 2 cos x. In the numerator, we are having only 1 cos x. So we will put here outside half. So that entire equation on the numerator, if you simplify, still you will get cos x back. So this substitution, we have to remember. We have to take first conversion of tan x to sin x by cos x. Then after finding the denominators LCM and then simplifying, you will be getting cos x dx divided by cos x plus sin x. To this numerator, you add this so that the substitution work now comes into picture. Now next step, what I'm doing, half into cos x plus sin x plus cos x minus sin x. That is what we are having now. So what I do, this entire thing I will divide like this. Cos x plus sin x divided by cos x plus sin x as a first bracket up to this. Second bracket, this half now I'm making common, okay, because it's common to entire thing. What are left over now for you? Cos x minus sin x divided by cos x plus sin x. Whole thing divided dx. This is one integral. This is second integral. So cos x plus sin x divided by cos x plus sin x dx. Cos x minus sin x divided by cos x plus sin x dx. Okay. Next step. See, this and this will go away. Only dx will remain here. Now here, method of substitution. Put cos x plus sin x is equal to t. So next step. Integral. Half is outside. After cancellation, you will remain with dx. Here, integral substitution is what for you? Okay, first I'll write down some what is remaining. This is what you are having now. So for this fellow, we will write down, put denominator part as t. Cos x differentiation minus sin x differentiation cos x differentiation dx by dt you can write down. So therefore, this entire thing becomes now cos x minus sin x dx is equal to dt. So if you see the second integral, numerator part became dt. So now we'll come back to the sum. Half, open the bracket. Integral dx means x you write down. Plus this half I'm sending inside. Half into integral dt divided by t plus c. This entire thing now becomes x by 2 plus log t by 2 plus c. Now you substitute your t back. Log of cos x plus sin x. Understood now? So we have taken the substitution and then completed this sum. Next sum will do. In this sum, very simple, but you have to remember. Substitutions you have to remember. This is the second sum. Integral root of sine 2x cos 2x. These sums I have taken from your NCERT textbook of a 12th standard. Please remember. So here also this is method of substitution. Put sine 2x is equal to t. Now don't confuse yourself by telling cos 2x is equal to t. So sine 2x also, but root symbol is there here. So therefore it is easy to do this way. Sine 2x you put to t, then differentiation will become cos 2x, 2x differentiation 2, dx by dt. All things we should remember. 2x we should not forget to differentiate because it's chain rule. So therefore 2 cos 2x dx is equal to dt. Here I am writing now differentiate with respect to t. This is previous sum also I think better I will write. Where I have to write that? Differentiate both sides with respect to t. Then only this term comes. Okay. So remember to write 2 cos 2x dx is equal to dt. Then cos 2x dx will become dt divided by 2. So observe here, cos 2x dx is there. You can replace this one with dt by 2. Root of sine 2x will be replaced with root t dt by 2. So bring out the half, root t. This is equal to half into t to the power of half plus 1, half plus 1 plus c. T to the power of 3 by 2 by 3 by 2 plus c. See, this half is there outside, remember. So now this 2 will go to the top and get cancelled with it. So what I can write now? Half, write down no problem. T value, sine 2x whole to the power of 3 by 2 into 2 by 3. This 3, 2 cancel. So we are only left with sine 2x whole to the power of 3 by 2 by 3. This answer, final answer. Sine 2x whole to the power of 3 by 2 plus c. After cancelling 2 and 2. Okay. So these are all method of substitution sums what we are doing now. Next, another important sum you see here. Question number 3. Integral x plus 1 x plus log x whole square whole thing divided by x dx. So let us call now substitutions now. Put x plus log x is equal to t. So differentiate both sides with respect to t. Then what happens? X differentiation 1, log x differentiation 1 over x is equal to dt. Here dx. This is dx. Is equal to dt. So if you simplify this, x plus 1 by x dx. Now you see the sum. X plus 1 by x dx, all are there. So entire term will become dt now. So now this implies integral x plus log x is called t for you, whole square is there, dt. Because x plus 1 by x became for you dt. This x plus log x became t, whole square is there, t square. So this becomes t cube by 3 plus c. Power rule we have to apply. X plus log x whole to the power of 3 by 3 plus c. Hope you have followed. Important sum. Next sum. Root of tan x divided by sin x into cos x. Okay. So now what we do here, we will write root tan x into sin x by cos x. Root of sin x by cos x whole thing divided by sin x into cos x. So now root sin x, you just split it like this. Denominator on sin x is there. This root cos x, write down here. Here another cos x is there. Next step. This root sin x divided by sin x. This will become root of sin x now. Correct or not? Yeah. Then sin x by cos x. Now I will do one small substitution here. Actually, this sum we will do in a different way. It will become easy for us. I'm just transforming this sum like this now. Instead of taking these substitutions, I will do another method so that it will become simple for you. Simplest way will do. Sorry, just little bit. Yeah, time will take, no problem. Here, sin x into cos x we are having, correct? Then what we do, we will multiply and divide by sin x, cos x. Sin x by cos x, write down. Another cos x, write down. This cos x as it is. So what we did now, we have just divided sin x by cos x and again multiplied, so that as it is, denominator doesn't change, but this will transform the sum like this. Root tan x divided by sin x by cos x will become for you tan x. This will become cos square x. Cos square x. Next, substitutions we can take. Put tan x is equal to t, so that secant squared x dx will become dt. So now here we observe 1 by cos square x dx is called as secant squared x. So in this sum, little bit one more step I'll put. Now tan x is equal to t. So this becomes root t divided by t into dt. Root t means t to the power of half. This is root. This root t will go root t times here. So if you simplify these two, you will be getting t to the power of minus half. T to the power of minus half. Because this is plus half, 1 will go to the top, half minus 1. So t to the power of minus half, you can verify this. So now you can apply the power formula. Integral t to the power of minus half dt you are having. So t to the power of minus half plus 1 minus half plus 1. So t to the power of plus half, then divided by half. So here integration symbol will not be there. So this is the final answer now. We'll convert it back to tan x. Tan x whole to the power of half divided by half plus c, or simply root of tan x plus c. Okay, so this is done. These sums we have to only by repeatedly solving, you remember. Next, one more sum we'll do. Integral x cube sine tan inverse x to the power of 4, all these sums from your NCERT, divided by 1 plus x to the power of 8 dx. Okay. So this sum, very, very important and useful sum for your examination. Put tan inverse x to the power of 4 is equal to t. You know that tan inverse x, what is the fundamental? 1 by 1 plus x square. Differentiation. That we'll use here. Differentiate both sides with respect to t. Then what will happen? Tan inverse x to the power of 4 differentiation, 1 by 1 plus x to the power of 4 whole square, x to the power of 4 differentiation 4x cube, then dx is equal to dt. Now dx by dt will come, cross multiplication, all that you have to now do. That's why I directly wrote dx is equal to dt. Then this one 4 into 2 will become 8. Dx is equal to dt. So this 4 you bring it under dt. So x cube divided by 1 plus x to the power of 8 dx is equal to dt by 4. So now x cube by 1 plus x by x to the power of 8 is here. So you can replace that with dt by 4. Top sine tan inverse x4. So sine tan inverse x4 you are calling as t. So that will become now sine t dt by 4. So 1 over 4 integral sine t dt will remain. That will become 1 by 4 minus cos t plus c. So minus 1 by 4 cos t is equal to tan inverse x to the power of 4. Done. So remember this. So last sum in this session. Integral e to the power of x 1 plus x divided by cos square e to the power of x into x. So this is the sum. So what we do now, we will call e to the power of x into x, that we put as t. In this sum, we'll call this as t now. So UV method, we will differentiate with respect to t. Then first function into differentiation of x1 plus x into differentiation of e to the power of x is equal to dt. This entire thing is dx. So put the bracket. take out e to the power of x common. 1 plus x dx is equal to dt. Okay, now? So now you saw here e to the power of x 1 plus x dx is there, which has become dt. Cos square t will come here. So finally our sum is becoming now e to the power of integral. Just go to the previous page and see e to the power of x 1 plus x dx is equal to dt. So numerator entire thing became dt. dt by cos square t. dt divided by cos square t. You write it as secant squared t dt, which is nothing but tan t plus c. Tan t is nothing but tan x e to the power of x plus c, because we called t as x e to the power of x. So last one, integral cot x log sin x dx. This we are supposed to know differentiate. What we do, put log sin x as a t. Log sin x is nothing but 1 by sin x. Sin x differentiation cos x. So cos x by sin x is dx is equal to dt. Cot x dx will become now dt because cos x by sin x is called cot x. So in the numerator we are having cot x dx, that can be replaced by dt. Log t will work. Log sin x itself is t. So now integral t dt. So that will become t square. Observe now clearly. T is nothing but log sin x. Dt is nothing but cot x dx. That's what we got here. So now t square by 2. T square you replace with again log sin x. Log sin x whole square. So friends, hope you have got now some command or grip over the method of substitution sums. Keep repeating, and any doubts are there you can leave in the columns. Now next task will go in the next video class on again differentiations or integration of certain trigonometric functions. That one we will try to do the sums. Then till then you practice these classes regularly. It will be useful because your examination dates hope announced. It will be useful for you. Keep practicing. Thank you.